My tech demo 2. In this video, I will walk through 3 tasks using GeoGebra 3D graphing calculator and Desmos. I will graph a surface, a contour plot, and finally a tangent plane. First, I'm graphing the function f of x and y equals 1 over 2x to the cube minus y to the cube plus 4xy in this GeoGebra 3D calculator. This function contains both cubic and linear terms, which gives it a complex surface with twisting shapes, saddle points, and steep peaks and valleys. To make the graph informative and visually clear, I selected a viewing window with x and y both ranging from -5 to 5 and z ranging from 40 to 40. By limiting the z range, we can clearly see the general shape of the surface, including how it bends, curves, and changes direction depending on the values of x and y. This visualization will help when we later examine the contour plot and tangent plane, because it gives us a solid understanding of the overall 3D structure of the function. For task 2, I created a contour plot of the function f of xy equals 1 over 2x to the cube minus y to the cube plus 4xy using Desmos, which is great for 2D graphing. Contour plot shows level curves where the function equals constant values. These represent horizontal cross-section of the surface. I plotted 7 curves where z equals -30. I wasn't able to label each of them because I didn't know how. But you can see here the red, which is z equals -30, green -20, purple -10, black is 0, orange is 10, blue 20, and z equals 30. Each curve is color-coded. I adjusted the viewing window to focus on x and y from -5 to 5, which highlights the interesting structure of the function. This visualization shows where the function is increasing or decreasing rapidly. Tightly packed curves represent steep regions, while wider curves shows flatter areas. The looping and bending of the curves also suggests saddle-like behavior where the surface curves in opposite direction. For task 3, I will be graphing the tangent plane to the surface. So we originally had f of x and y is equals to 1 over 2x to the cube minus y to the cube plus 4xy, and we have a point where 2, -1, and -3. To do this, I first calculated the partial derivatives, where f of x equals 3 over 2x to the square plus 4y, and f of y equals -3y squared plus 4x. And if we plug in 2 for x and -1 for y, for f of x we get 2 and f of y we get 5. And we can use the tangent plane formula where therefore we get the formula where z equals 2x plus 5y -2. I graphed both the original surface and the tangent plane in GeoGebra. I also plotted the point 2, -1, -3, which lies exactly on both the surface and the plane, as you can see here. As you can see, the plane just grazes the surface at a single point and does not intersect or cut through it locally. This confirms that the plane is tangent to the surface. It shares both the height and the slope of the surface at that exact location. This is what makes it a tangent plane. It lies flat against the surface at just one point and points in the same direction as the surface there. As I rotate the 3D view, notice how the plane barely intersects the surface beyond point A. That visual reinforces that the plane and the surface are only touching at one location, not intersecting broadly. Thank you.